Hello students, myself Ranjana Patil. Now we started the chapter ionic equilibria from the 12th science from the new syllabus from the part first. Okay. So when I consider the word ionic equilibria, so what is mean by the equilibrium or equilibria? So equilibrium, it is a state or in the chemical reaction. Equilibrium, it is a state in the chemical reaction where the concentration of the reactant and products do not change with the time. They are remains constant. So concentration of reactants and products remains constant. They do not change with the time. And at that time, that equilibrium we called it as a, that point is called as a equilibrium. Okay. So there are various types of the equilibrium we are considering. The first is a thermal equilibrium. In thermal equilibrium, thermal means heat or temperature. Here the temperature is remains constant, then we are called it as a thermal equilibrium. Then chemical equilibrium. In chemical equilibrium, the equilibrium which is occur during the chemical processes. Here temperature constant. The equilibrium which is occur in chemical process or chemical reactions are called as chemical equilibrium. Then physical equilibrium, which is equilibrium which is occur in the physical reaction or physical processes. In physical processes. And one more equilibrium is the mechanical equilibrium. The equilibrium in which no matter, no change in matter is occur. No change in matter is occur. So when I consider equilibrium, thermal equilibrium, here the temperature is remains constant. Chemical equilibrium, here the equilibrium is concerned with the chemical processes or chemical reactions. Physical equilibrium, it is equilibrium which are considered with the physical processes. And mechanical equilibrium, where no change in the matter is occur. So this type of the equilibrium we are considering when I consider the term as a equilibrium. Now, what is a ionic equilibrium? Now, what is a ionic equilibrium? So, ionic equilibrium is the equilibrium which are exist between ions. Between ions are called as ionic equilibrium when the ions are in contact, when the electrolyte or when the compounds are dissolved in the water. At that time, the equilibrium is occur as a ionic equilibrium. Or chemical equilibrium in aqueous solution between unionized or undissociated molecules of electrolyte with ions. Look here. So what are ionic equilibrium? The equilibrium between the ions is called as ionic equilibrium, or chemical equilibrium in aqueous solution between unionized or undissociated molecule of electrolyte with the ions. For example, if I consider water, if water is allowed to dissociated, it can dissociated as H plus and OH minus ion. If I consider acetic acid, it is a weak acid. When you dissolve in the water, it can reduce acetate ion and H plus ion. Or if I consider HCl in aqueous solution gives H plus and Cl minus ion. Or salt, NaCl, KCl, when reacted with the water, they give Na plus and Cl minus ions. Right here. Na plus and Cl minus ions. So like this way, we can consider the type of the equilibrium in the ionic equilibrium. So ionic equilibrium, the equilibrium between the ions with the ionized or undissociated molecules. Okay. So these are the various types of the equilibrium are concerned when I consider the ionic equilibrium. So we consider here one of the point is the equilibrium in which the molecules are undissociated with the undissociation with occurs with the electrolyte. Okay. So what is electrolytes and how these electrolytes are considered with the ionic equilibrium? So electrolytes are the substance. Electrolytes are the substance which gives ions, which gives ions in aqueous solution. Electrolytes are the substances which gives ions when dissolved in the water or in the aqueous solution and conduct conduct electricity in molten or in aqueous state. Look at. So what is electrolyte? Electrolyte is a substance which when dissolved in the water, that is in aqueous solution, gives ions. They produces the ions. And second, as because of the ions, they conduct the electricity in molten and in aqueous state. Then we can say then another point is that non-electrolyte. Non-electrolyte. So what are non-electrolytes? They not produces or not use ions in aqueous solution. They does not produces ions in aqueous solution and not conduct electricity in molten or in aqueous state. In many form, it will be not conduct the electricity are called as a non-electrolyte. So what are the example of the electrolytes? Electrolytes are the strong acid, strong bases, or you can say that acid and base, because weak is also there, it can be ionized but in a less proportion. So I say that acid, bases and the salts are the electrolyte. Non-electrolyte are the substance which does not produces the ions. For example, glucose, urea, sugar. These substances never ionize and never conduct the electricity, so the non-electrolyte. So what are the electrolytes? Electrolytes are the acids and bases and the salts. Acids, bases and the salts. Whether the acids are strong acid or strong bases, depending upon this, the electrolyte can be further classified. So I can revise: electrolyte substance which gives ions in the aqueous solution and conduct the electricity. Non-electrolyte will be not use the ions in aqueous solution and not conduct the electricity in molten or in the fused or aqueous states. Okay. So electrolyte now further classified as a strong electrolyte and the weak electrolyte. So what are the strong electrolyte? Strong electrolyte and weak electrolyte. So when I say strong electrolyte, the strong electrolytes are the substances as they are completely dissociated and therefore they use a large number of the ions. They use large number of ions on dissociation. They use less number of ions on dissociation. So are the weak electrolytes. As they give large number of the ions on dissociation means their complete dissociation is occur. For example, HCl is a strong acid when dissolving water gives H plus and Cl minus, as their 100% dissociation can be occur. So therefore, in a strong electrolyte we are considering example as a strong acid, strong base. Suppose NaOH when dissolving water gives Na and OH minus ion. Here 100% dissociation can be occur. If you consider NaCl, when I dissolve in the water, it gives Na plus and Cl minus ions. So their 100% dissociation is occur. So therefore their degree of dissociation alpha is a near about 1 for the strong electrolyte. So why the degree of dissociation is 1 for the strong electrolyte? Let us consider, suppose I have the 100 moles of the HCl and when I dissolve, they give 100 mole of H plus ion and 100 mole of the Cl minus, means they are completely dissociated and therefore the dissociation is 100% and therefore total number of the ions produced are 100 out of the 100. So 100 divided by 100 is 1. But actually number of the ions are dissociated are 100. The actual number of the ions dissociated is from actual number of the ions taken or molecule taken is 100. So therefore the degree of dissociation for the strong electrolyte, whether they are strong acids, strong bases or the salt. So what are the example of the Strong electrolyte, strong acids, HCl, then HNO3, strong bases, NaOH, KOH, or the salts such as copper sulfate, NaCl, KCl, silver nitrate. So all these are the example of the strong electrolyte. So when you consider the weak electrolyte, in the weak electrolyte, they are substances, they are less dissociated. So we consider example as a weak acid and weak bases. Weak acids and weak bases are the example of the weak electrolyte. For example, formic acid, acetic acid, or carbonic acid, hydrogen cyanide. All these are the, when dissolved in the water, they dissociated in a less proportion. Their partial ionization can be only occur. They are not completely ionized. Okay, so therefore I write a two-headed arrow. Acetic acid can be dissociated as CH3CO plus H plus. The partial dissociation is there. Carbonic acid also have the partial dissociation. SCN also have the partial dissociation. So like this way, the weak acids can be dissociated here. Weak bases such as ammonium hydroxide can also shows like this way, dissociation in the aqueous solution. Okay, so weak acids and weak base, as they are not completely dissociated in aqueous, so therefore they are called as a weak electrolyte. The second thing is that suppose we are taking the 100 moles of the formic acids, out of the 100 mole only 2 or 3 or 5 moles is the dissociated, then their dissociation is a less than 1. So therefore for a weak electrolyte, the dissociation is a less than 1. So this, remember this difference between the strong electrolyte and weak electrolyte, that weak electrolytes are 100% dissociation. So therefore our degree of dissociation is 1. Here the degree of dissociation is a less than 1. It is a fraction quantity. Okay. So now what is a degree of dissociation we consider? What is the degree of dissociation we consider? Okay. So degree of dissociation. Degree of dissociation. So degree of dissociation, it is indicated by alpha. It is the fraction of total number of the moles of an ions of the electrolyte which actually dissociated when the equilibrium is attained. It is the fraction of number of ions of electrolyte produce at equilibrium. So when any electrolyte will be dissolved in aqueous solution, and at that time how much ions, alpha is a number of ions produced or dissociated in aqueous solution out of the total number of ions. How much is the total number of ions actually, from which the number of the ions actually produced or dissociated in aqueous solution? This gives a ratio. So we know that for the strong electrolyte, the total number of the ions produced and total number of the ions actually, they are same. So the value is 1. In case of the weak electrolyte, this quantity is very less. Suppose it is a 5 number of the ions actually produced out of the 100 molecules, then alpha is a 0.05. Okay, so therefore the degree of dissociation in the case of the weak electrolyte is a less than 1. Okay, that is clear. So percentage dissociation we can also consider by multiplying alpha with the 100. I get a percentage dissociation. So here 5% can be dissociated by the weak electrolyte. Okay, so therefore it is a weak electrolyte. Okay, so like this way we can consider one concept is that what is the ionic equilibria and what is the electrolyte. Now one point of difference we again consider, what is the difference between dissociation and ionization. Let us clear this term, dissociation and ionization. So when I consider ionization, ionization is considered with the polar covalent molecule. It considered with the polar covalent molecule, and dissociation is considered with the polar compounds. Look at the difference is that polar covalent molecule such as HCl gas, which has actually not ions, but when you dissolve in water they use H plus and Cl minus ions, so they are ionized. So polar covalent molecule are actually ionized, and the uh, ionic compounds and the ionic compounds are actually dissociated. For example, NaCl, KCl. NaCl already have the ions, the KCl already have the ions, and when dissolved in the water, what happen? There is only separation of the ions can be occur. Here, there is a separation of the ions can be occur. So therefore, I say that polar covalent molecules are ionized and ionic compounds can be dissociated. So they are already ions. They are only separated. So this is dissociation, and here there is no ions, but when you dissolve in water, then they are produces the ions. In that time, you can use a word as an ionization. So that difference we will remember in the ionization and the dissociation. Now next point is we know that in our day-to-day lives we are using a number of acids and bases. So the acids we are using such as acetic acid in a vinegar, citric acid in the lemon, or we are using a magnesium hydroxide from the antacids. We are using ammonia. So these are the in day-to-day life the number of acids and bases we are using. Now we are considering the various definitions of the acids and bases depending upon the various scientists, which is given by the various theories. First, we consider Arrhenius theory. So now write heading theories of acids and bases. First is the Arrhenius theory. So according to Arrhenius theory, how we can define acids and bases? So according to the Arrhenius, acid is a substance which possesses or which has H and produces H plus ion in aqueous solution. Okay. So what are acids? Acids, according to Arrhenius, acids are the substances which has H plus ion, produces H plus ion in the aqueous solutions, are only called as acid. For example, HCl is not an acid. It has H plus ion, but when it is dissolved in the water, it gives H plus and Cl minus ion. So it is an acid. Again, base is a substance which has OH and produces OH minus ion in aqueous solutions are called as a base. Look at. So what are acids? Acids are the substances which already have H plus ion and which produces H plus ion in aqueous solution, then it is an acid according to Arrhenius. Base is a substance which has OH minus ion and which produces OH minus ion when dissolved in the water, then and then it is a base. For example, NaOH, KOH, they have the OH minus ion, and therefore when they are dissolved in the water, they gives OH minus ion, therefore they are the base. If they have no OH minus ion, they are not base. For example, your ammonia or your sodium carbonate, they are not bases because they does not have the OH minus ions. Similarly, if you consider the metal oxides, metal oxides such as a sodium oxide, magnesium oxide, okay, or you consider SO2 or CO2 or N2O4. So these are the various types of the metals and non-metals oxide. So metal oxides are basic in the nature and non-metal oxides are acidic in nature. So all these metal oxides are not considered according to the Arrhenius theory because they does not have H and OH minus ion. So according to Arrhenius, so this is drawbacks of Arrhenius, that Arrhenius can explain only those acids and bases which have H and OH ion. Those which does not produce H plus and OH minus ions are not acids and bases according to Arrhenius theory. So Arrhenius consider only the hydrogen and OH having acids and bases. It not consider the metal oxides which are actually the basic oxide. It will not consider the nature of ammonia or sodium carbonate, which may also show the acidic and basic properties. Okay. The second theory now we consider is the Lewis acid base theory. So according to Lewis, what are the acids? So according to the Lewis, acids are the proton donor. Proton donors are the acid. And what are the base? Base are the proton acceptor. Proton acceptors are called as a base and proton donors are called as acid. Okay. So suppose I consider HCl is reacted with ammonia. So here HCl is an acid because when HCl will be donate hydrogen to ammonia, base will be accepted. So ammonia is a base. So HCl when donate a proton means hydrogen. Proton means hydrogen. So hydrogen donor and hydrogen acceptor are the Lewis acids and bases. So HCl when donate proton, it gives a Cl minus. The NH3 which is a base will be accept the proton and therefore it gives NH4 plus. Okay. So HCl is an acid. The corresponding is called as conjugate base. When acid will be used H plus ion, it is a acid. It gives H plus ion. The corresponding Cl minus ion will be generated is a conjugate base. Ammonia is a base which will be accept the proton from this. So whatever the corresponding is obtained is the conjugate acid. So the Lorry and Bronsted will be also consider the conjugate acid base pair. For example, HCl is a acid. HCl acid has a conjugate base as a Cl minus. Okay. Suppose H2SO4. It will be donate hydrogen will be used HSO4 minus. So it is a conjugate base. HNO3 when donate hydrogen it gives NO3 minus is a conjugate base. HSO4 further able to donate hydrogen, so it is a produces the SO4 minus 2, so it is a conjugate base. Okay. HCN when donate hydrogen it gives Cn minus, so it is a conjugate base. H2CO3 when donate hydrogen it produces the conjugate base HCO3 minus. HCO3 minus is further able to produce the conjugate base CO3 minus. Okay. So what you observe? The acid and conjugate base pair, they are differ by the difference of the hydrogen, that is the proton. They are differ by the difference of the hydrogen than the proton. So what is the conjugate acid base pair? So conjugate acid base pair are the pairs are differ by the difference of proton. They are just differ by the protons. So just by proton donation and acception we can produce the conjugate acid base. For example, HCl, what is the conjugate base of acid HCl? So Cl minus. So here the conjugate base is produced by the loss of proton and conjugate acid is produced by the acception of the proton. So this conjugate acid pair can be considered. Okay. So acid, we can write the conjugate base. Similarly, if you have the base ammonia, then ammonia will be accept the proton. It use NH4 plus. So this is a base and this is a conjugate acid. This is the conjugate acid. So acid donate proton, so therefore by the loss of the proton we can produce a conjugate base. Base will be accept the proton. So by the acception of the proton, we can produce a conjugate acid. So like this way, we can produce a conjugate acid and base pair. So what are the drawbacks of Lewis acid-base theory? Acid-base theory can consider the property of acid and bases only in the terms of the proton. Those which does not possesses the protons are not conjugate acid and base, are not acid and base according to Lewis acid-base theory. It also not consider the reaction between the acidic oxide and basic oxide. Acidic oxides, for example, CO2 or SO2, so or basic oxides such as sodium oxide or magnesium oxide or calcium oxide, as they are acids and bases, and if they reacted, so their reactions are not considered in Lewis acid base there. So what are the drawbacks of Lewis acid base there? The Lewis acid base consider acid and bases only in the terms of proton, and it will not consider the reaction between the acidic and basic oxides. Okay. Then the next is the Lewis theory. Next, third theory is the Lewis theory. So what is the Lewis theory? Lewis will be consider the definition of acid and base. Lewis will be consider the definition of acid and base in the terms of electron pair. So electron pair donor, electron pair donor are the bases, and electron pair acceptor, electron pair acceptor are the acids. Remember. So electron pair donors are the bases and electron pair acceptors are the acid according to Lewis theory. For example, H plus when react with OH minus ion, here OH minus ion will be donate a lone pair to the H, and therefore it forming the water is like this way. So according to Lewis, there is a H plus ion donor is a base and H plus ion lone pair